So now I want to bring your attention to these horizontal lines. Sometimes you can even see some vertical lines. And sometimes we will get these lines with a sparse solver if we have fast moving volumes, which is the case here. So if you take a look at the wireframe, you will notice that the sparse volume is created by these blocks of information. So where we don't have voxels, the solver will try to optimize the information, and that's where we're getting these missing parts of the volume. So what I'm going to do to avoid these lines is, first of all, go into the Solving tab, into the Advanced tab, and look for the padding. The default value is 0.3. Currently this simulation is quite large. If you take a look here under the PyroSolver's information, you will notice that the simulation is currently almost 12 meters high. So we can try to increase this padding. Let's try with 2 meters. This will increase the size of these blocks, so we have more room for the density to be accommodated. So let's go back to Smooth Shaded. Let's go back to frame 1. And again, let's run the simulation for a few frames. Now, although I'm pretty sure that the padding will help, sometimes the padding is not enough. And sometimes the only solution is to increase the substeps under the simulation global substeps. But let's see the result first, and then we can decide if we can increase the substeps as well. I think it's looking much better. Now, a very important thing that I mentioned at the beginning of this tutorial is that we want to use a realistic scale for this scene. And as we saw, this simulation is almost 12 meters high. So what I'm going to do is scale down this volume. We can add a transform node and bring the scale down to 0.05. So now let's take a look at the size. You can select the transform node, check its information, and now its size is around 75 centimeters, which is much more realistic. So the size of the volume will be very important when we add lights and real-world camera values. Okay, so speaking about camera, let's try to frame the ink in a nice way. So one thing I want to avoid is to see the emitter. I'm going to zoom in, and I'm going to frame the ink so we cover the entire frame with it. Once that is done, you can go to the camera menu and click here in new camera. So this will create a new camera from the current perspective. Okay, so let's now take care of the caching. Go back to the ink geometry, select your PyroSolver, and there's one very important thing that I usually do before caching. First of all, go to the Export tab and make sure the Convert to VDB is on. Also make sure that the Use 16-bit float option is on. This will reduce the file of the volume considerably. And lastly, let's make sure that all the necessary fields are being exported. So of course we will need the density. We will need the velocity to advect some particles later on. In this case, we won't need to export temperature nor flame. And finally, we will need to export the color. And remember, we can always increase the density of our volume using its look or its material. So let's add a ROP geometry node. Connect the geometry output to the transform. Let's change the name of this node to Ink Sim. And finally, let's make sure that we're caching the entire frame range. And one more thing before I forget. Let's go back to our PyroSolver. Let's increase the resolution. So I will change the voxel size to 0.025. And now I think we're ready to cache the simulation. So go back to your ROP geometry output and click on the Save to Disk button.